Let's move on to the speed time graph. There are two particles here, they are going to move in a certain fashion. Let's go through the move and then we come back to discuss. So just follow what I'm going to do now. Alright, so let's go back. The two particles are moving and the motion is a bit different from what we saw earlier on. Now, the blue particle was, at the time, immediately we started the clock, the blue particle was already moving with a speed of 20 millimeters per second, but the red particle was stationary. The speed was 0. Remember, we've now changed the distance to speed for this table here. Let's see, 1 second later, the red particle moved to 12 and the blue particle moved to 20. What are the speeds for the two particles? For the blue particle, it moved from 0 to 20 within 1 second. So the speed will be the distance covered, which is 20 divided by 1 second. This gives us 20 millimeters per second within the 1 second. Then for the red particle, it moved to 12 millimeters within the first second. So the speed will be 12 divided by 1 second, which gives us 12 millimeters per second. Let's move on to the second. Let's move on to the next moment, which is the second. At this point, the red particle moved about 24 millimeters. From here all the way to this part will be 24 millimeters. And 24 millimeters within 1 second will give us 24 millimeters per second. You see that it was moving slower and later on picked up speed. Let's look at for the blue. The blue moved from 20 millimeters to 40 millimeters. So the distance covered is still 20. Initially it was from here to here, it was 20 within 1 second. And from here to here within another 1 second. So the speed remains the same. Let's move on. We can see that the red particle has shot to 72 millimeters. That's the position now. And what distance has it covered from here all the way to the side? And that will be 36 millimeters. It has traveled 36 millimeters within 1 second, and the speed will be 36 divided by 1 second, and that gives us 36 millimeters per second. What about the blue particle? Again, it moved from 40 to 60, a distance of just 20 millimeters within 1 second, and the speed, if we calculate it, will remain at 20 millimeters per second. So clearly, the blue particle is moving with a uniform speed, a constant speed, and the red particle is increasing in speed. Is that okay? It is increasing in speed. So we see the red particle is accelerating, or it is increasing in speed. Is that okay? Let's see how this one goes to a motion graph. Remember, the vertical axis, because we are talking about speed time graph, the vertical axis will go for the speed. Sorry, I should have mentioned, I should have written millimeters per second here, so you can include it in your own portfolio or in your own notes. Okay, so for the blue one, we have the particle starting its journey with its initial speed of 20 millimeters per second, and it maintained that uniform speed throughout the whole period. So a graph for a constant speed will be a horizontal line, and a graph for a particle increasing in speed or accelerating will be a slope, will have a slope, and the gradient for that slope will now be the acceleration. Remember, when it was distance time graph, the gradient for the curve, or for the curve, was the speed. But for the speed time graph, the gradient will represent acceleration. So keep this point in mind. Now let's summarize the whole thing, and these are the things I've been talking about. Just keep note of them. I only need to mention that the y-intercept will represent the initial speed, and then the area under the curve will represent the total distance traveled. Let's see how we can put this into practice. Now, this is a speed time graph for us here to interpret. It has about four different sections, but we are going to talk about everything here. Now, it started from the origin, and the speed was 0. Then it started moving until this point. During this session of the journey, it was accelerating because the speed was increasing. The speed was increasing, so it was accelerating. If we had figures on the axis, then you could calculate the gradient, but we don't have any figure on the axis, so we just describe it. So it was accelerating, it was increasing in speed. This side, during this side, it was the acceleration was decreasing. The acceleration was decreasing because the gradient is decreasing until the gradient became 0 here. Now the gradient here is 0. That's, we have a horizontal line for this motion, for this part of the motion, and that represents a constant speed. At this time, it was traveling with maybe 50 meters per second. At this time, 50 meters per second, 50 meters per second. It means it was traveling with a uniform velocity until we got to this point. Then it accelerated further because it is increasing in speed. Then suddenly it reduced speed, that's decelerating, and continued decelerating until it came to this point. You can try to interpret the whole motion graph for yourself. You can put more points, maybe 1, 2, 3, and try to interpret the various sections yourself in detail. Now let's look at example 5 here, still speed time graph. So let's start with the first one. So between 0 and 10 seconds, we are supposed to calculate the acceleration. We can choose this big triangle, taking this point and this point into consideration. In that case, the vertical change will be 20 meters per second. That's the final velocity minus the initial velocity. So 20 minus 0, that gives us 20 for the numerator. And when it comes to the denominator, it will be the horizontal change between the 2 points. So it will be the final time minus the initial time. That's 10 minus 0. So the numerator will be 10. So 20 divided by 10 gives us 2 meters per second squared. The gradient for speed time graph will leave us the acceleration. So 2 meters per second squared. That will be the acceleration for the first 10 seconds. Let's look at what was the acceleration between 15 seconds and 25 seconds. So from the simulation that we had, a horizontal line for a speed time graph will have acceleration of 0. It is not accelerating, it is moving with a constant velocity. At 15 seconds, it was moving with 10 meters per second. At 20 seconds, it was moving with 10 meters per second. At 25 seconds, it was moving with a speed of 10 meters per second. So 10 meters, 10 meters in that order. So it is moving with a constant velocity, and that means that the acceleration is 0. Now we are supposed to determine the distance traveled during the first 15 seconds from here up to here. So we need to break. So we are going to calculate the area under this curve, this portion of the curve from here on to the side. And area, we do it as length times breadth. If it is a triangle, we use the half base times height. So for this graph, they've divided it into one triangle here, one big triangle here, then another small triangle here before a rectangle here. You just have to calculate the individual areas and add them up. For example, we have the height here to be 20 multiplied by the base, which is 10, then we halve it. 20 times 10 will give us 200, then we halve it. So this distance for this side, the distance for this side alone will be 100 meters. Then we can calculate the area here and calculate the area here. We have the sides. You do that and share your answers on the platform. Alright, so that's it for the motion graphs. There will be more examples for you in subsequent videos. Thank you.